good morning, good afternoon, and good evening. Welcome to another edition of the ITU AI and Machine Learning 5G Challenge webinar series. My name is Thomas Bascolo, and welcome to today's webinar. The AI and Machine Learning 5G Challenge is organized by the ITU, which is a United Nations agency for ICTs. The mandate of the ITU is to allocate frequencies to services that use the radio spectrum, to develop standards, and to assist developing countries in setting up their ICT infrastructure. The aim of the challenge is to create a community that will solve network-related problems using AI and machine learning. I would also like to inform you that this challenge is kindly sponsored by Xilinx, and we are grateful for their sponsorship. Now it's time for me to introduce today's speakers. Today we are lucky we have colleagues from St. Petersburg State University of Telecommunications. We have Amar Mutana, who is the associate professor at the university, as well as Abdulkadir Kakimovi, who is a junior researcher as well as a PhD student. We are supposed to have another colleague, Atem, but due to some problems, he couldn't manage to make it. But we are glad that we have Amar and Abdul for this session. In today's talk, they will discuss an architecture that is going to be used to provide services migration between fog and edge computing structures, as well as elements based on information about computation and network capabilities by taking into account user query statistics in each of the fog structures. The solution can be used for IoT-based application development as well as deployment, which provides new time constraint services such as tactile internet, autonomous vehicles, etc. Furthermore, the talk will describe a platform and services placement using the genetic algorithm to analyze and predict services. So welcome Amar and welcome Abdul. Good afternoon.
Yeah, thank you for invitation, and thank you. This is our second time to participate in this event. Last year, we organized one host by St. Petersburg State University of Telecommunications, so a Russian host. And yeah, it was helpful. We collaborate with, we prepare many projects from our side, and one of them participate in final with, this year we decided to change the area about edge computing and surface migrations, but the host of this year is about forecasting model for surface allocation network using traffic recognition. But this talk, we are going, in this talk, we are going to explain what's the edge computing and what is surface migration. And I decided to start this with 6G networks because to show what kind of applications will be in future and what kind of problems, challenge, which require to some new solutions. Many of my colleagues already started to show many solutions based in edge computing and artificial intelligence and so on. But in this talk, we add surface migration for edge computing. So firstly, I have to talk about application challenge in 6G networks, and then edge computing. What kind of challenge in edge computing? After that, there are two projects which already done with my team, with my colleagues Abdulkadir Hakimov and Artyom Volkov. Artyom, a project with DDFog, and platform with Abdul. So we will try to show these two solutions which already done, and after that we are We will continue explain the data set and the short about um, about the challenge. I did. So usually we started from the common feature with 5G standard, where is three category: ORL, machine type communication, and broadcast. So this in this presentation, I decided to start with this picture. So about 6G communication are expected to provide improved services in terms of coverage, data rate, and allow users to connect each other everywhere. So it's expected to adapt unconventional communication networks to access several types of data and transmit them through conventional improved radio frequency networks. So allowing new communication experience with virtual existence with virtual existence and involvement anywhere to explicitly define the probable future of 6G communications. Here we foresee the potential application scenario and challenge for 6G communications. So here we can see 5 application scenarios supported by 6G communications. The MP Plus supports the high quality conventional mobile communications, and the BigCom supports basic communications for remote areas, and the C how it's the SURLC in 6G is a joint upgraded of the ORLCC and the MTS machine type communication in 5G with higher requirements of how it's called reliability. The 3D intercom the 3D intercom raises the network optimization and planning diminution to 3. And the last one it provides the possibility to incorporate novel communication prototypes and paradigms. A qualitative comparison between 5G and 6G communications, the comparison is made that in terms of security, secrecy, and privacy. So spectral efficiency, intelligence, energy efficiency, and consumption, and so on. Based on the application scenarios and challenge, as well as the 5 supported application scenario in 6G, we are now able to define the key features of 6G. High security, secrecy, and privacy, high, for consumptions, low energy consumptions, and low battery life, high intelligence, extremely larger bandwidth than 5G, and trade-offs between key features and potential solutions. So proper place to start seems to be the question of why one even needs edge computing in general and mobile edge computing in practical. So much has been written on this subject, but it can be summarized as like There are applications for which the traditional cloud computing, uh, the traditional cloud computing hosting environment simply does not work. So this can happen for number of reasons. And some of more common of this area, the applications is latency sensitive or has latency sensitive components, and therefore cannot hosting in the traditional cloud. Application clients generate significant data, which requires processing, and it is not economical or perhaps even not feasible to push all these data into the cloud. So there are requirements to ration data locally, for example, within the enterprise network. So a big driver for edge computing is the Internet of Things, as we know, where edge computing is commonly referred to as fog computing. So the question is, what is mobile edge computing? What's mobile edge computing, and what does it look like, and how does it really work? So as edge server is a type of edge device that provides an entry point into a network. Other edge devices include routers, routing switch. Edge devices are often placed inside internet exchange points. So to allow different networks to connect and share transit. Uh, Simply, mobile edge computing capabilities, mobile edge computing as the way of moving cloud computing capabilities to the mobile network. So moving cloud computing to the edge of the mobile products, a lot of benefits can be summarized in the following points. Reduces the round trip latency of communications data, provides an efficient way for offloading data delivery to the core networks, provides higher bandwidth, and introduce a new service and applications by accessing the network context information. The landscape of the different mobile edge computing drivers, like drive from the various business motivations for its adoption, is currently quite diversified. In particular, the aspects which can be highlighted as the main KPI for infrastructure owners. So mobile operators and service providers uh, are uh, the delay improvement in terms of better end-to-end quality of service, quality and quality of experience, perceived by the end users. So thanks to the proximity and network utilization and cost saving, more efficient usage of backhauling and transport network, as the edge servers is conventionally routing locally used traffic. So energy efficiency and total cost of ownership, thanks to the small footprints of edge services and better improvements in site cost management, especially when also management of the computation and networks resources as well. We solve many problems. We had many works regarding to the edge computing. I mean, we develop uploading algorithms for that. In our works, we We work with offloading algorithms with some kind of platforms and to self in case when it will be many tasks, multitask with edge compute using artificial intelligence at the edge computing to solve problems with optimizations and so on. The question also about the location of the edge computing. So here we can see, I think all of you know this. So the cloud servers are connected to the LTE micropath stations, cloud units placed 3G radio networks, and so on. So this was like short about the edge computing and what kind of problems can solve. I mean, the edge computing also already standardized by and using by many companies, and I mean, it's one of the main components technologies in the future networks, 6G, 5G, and so on. So here I will show. So we have many works regarding the offloadings algorithm and so on. So, but in this, I would like to show one of our projects regarding to the microservice and service migration. So first project was done by my, by my colleagues, Artyom Volkov. He is not here today. I will try to explain some details about this project. This project is, it can be helpful in our challenge. Our challenge was done based on these two frameworks, this one and Abdul Qadir. So in this project was developed an intelligence distributed dynamic fog computing framework. Uh, uh, but first, I would like to show some terms. Uh, some terms like for computing, you already knows this term, but there are microservice and microservice live migration. Microservice pattern is an approach of software architecture designed based on software separation to logical part. For example, so product based on the MC solutions functions of the main service, such as neural network and so on. Microservice is a logical part of service software with interconnection with other microservice in order to provide the service life cycle can also can be presented by virtual machine Docker container. The microservice live migration, this is a process which includes the following steps. So copy of microservice with the current status, fog node defining for migration, allocation of the network resources, transfer the microservice copy to fog node, and microservice deploying microservice connection to service architecture for establish interconnection with other microservices. So this is the main terms which we will use in this project. In this slide, no, as general part of the idea is the current in this project is the microservice approach is in software architecture for time constraint services which will be deploying on the fog infrastructure. Where the microservices cloud represent the different levels of service software decomposition. For example, a microservice can be a small server based on the MFC pattern or independent class model or function. Service decomposition to the functional layer is the deep distributed software architecture. This architecture allows service to be distributed across the network on minimal fog devices. The contribution consists of the following features in the slides to use deep integrated fog and mobile edge computing technologies. The software of each service have to be based on the microservice architecture, monitoring of the consumer demand like artificial intelligence, monitoring of the load on the service and their components, microservices, based on the monitoring, making the prediction of user routes and their demand, and based on the monitoring, making the prediction of routes for microservice migrations via edge networks, and we use like device-to-device communication. And if the consumer demand are growing, we can copy the important microservices to the closely fog areas. For that, a lot of tasks we have to solve. So in this project, we consider the general framework processing, and as practical part, we consider the algorithms for defining the fog nodes for the microservice migration deployment, and also for defining the center of the user clusters. So according to the framework, we suggest the hierarchical system of the connected devices from fog devices, which can be dynamic to multi-level edge computing system, and processes between them, taking into account the user dynamic microservices support with their on-demand live migration. In our proposal, we consider the analytic application on the infrastructure service layer as the monitoring and control of the platform, of the part of the architecture or framework. So in addition, this application is divided into parts. The main application which is deployed in the center cloud, and the application which is deployed on the micro cloud or mobile edge computing. Micro cloud is responsible for appropriate the fog zones. So the use cases of this the system of picture improving based on the neural networks processing near with user, including the air augmented reality content preparing and virtual objects processing. So neural network processing for the air content and their virtual objects near with users. I mean augmented reality, and emergency services distributed near with accidents. So at the moment, we are investigating the issues of microservice migration and fog devices definitions. We define a practical swarm optimization algorithm as a tool for fog device definitions. So the first results showed that recent choice of the device based on particle swarm optimization can reduce the execution time of function by microservice on the around 70%. So so in this project in future The DDFOG include more than presented here research challenge as well as direction on the next step of these projects. I mean, expected to build a predictive model of users moving service dynamic, taking into account present results in the current work or project. So, for example, monitoring the consumer demand, taking into account their movement, monitoring of the load on the surface, and their component microservices based on the monitoring, making the prediction of user routes and their demand. Based on the monitoring, making prediction of routes for microservice migration via edge computing, and so on. So this was like about the first project, which was done in this area. Next, yeah, next about platform, we call intelligent platform for deploying of edge computing applications. I would like to invite my colleagues, Abdul Kader, to continue with this, and then we can together try to explain the last points. So Abdul Kader, please, your talk.
Hello, everyone. I will shortly talk about intelligent platform deployment application in multi-access edge computing. So today in telecommunication area, we have problems for deploying application to multi-access edge computing nodes. The main problem is optimal placement. Optimal placement, and for application to use minimum resource in specific period of service. The list of resource includes first use of communication channel, CPU, GPU, RAM, and etc. and others. Second, an efficient forecasting and live migration method of service as an application to edge computing systems, and approach can be utilized. This approach can be utilized the systems with an intelligent allocation of operator equipment resource for providing flexible and high quality topological organization. So we proposed the intelligent platform. This platform named REX, Resource Exchange Platform. It includes three main modules. First module is make owner interaction module and service make owner interaction module and the service provider. Second module application migration module, and third forecasting module or forecasting module. Three main modules, and in this picture you can see it's generally architectures of proposed algorithms. For example, we have network operators. It's network operators. It's maybe Vodafone, Orange, and others. We install REX client in network on infrastructure of these operators. In these operators, network operator has many Mac hosts or Mac nodes. Any Mac nodes has resource and Mac nodes, and this resource of this of the Mac nodes are CPU, bandwidth, GPU, and RAM. For example, in each Mac host, connect many subscribers, and all many subscribers. And the second and we have service providers. Service providers has it's maybe cloud gaming platform or video streaming platform, Netflix, YouTube, and then others, or IoT applications, or and all subscriber of these network operators usually every day using yes, internet service or internet application, and and every subscriber has own characters, and for optimization, for optimal placement application in this Mac host, we must first predict in what time which application is more load for group of subscribers. For a group of these subscribers, and all elements of this platform connect with API, and for install network operators and for install Alexa clients to operators infrastructure, we must connect with API to OSS or BSS systems of these operators, and check traffics and check available of host of Mac host. How it works. Internet network operators, REX platform in clouds, for example. Subscribers group is service provider. It's a cloud gaming service or Netflix or YouTube or IoT application and then others. And the publisher group is network operators. All network operators register their Macs on the REX servers based on 5 metrics. 5 metrics is durations, duration of how many times works how would like this application in this Mac. Second, how many RAM you will use this application, how CPU, how many CPU, bandwidth, and cost, how many dollars. And they are published in a series of REX, and when one of the Mac host is available and subscriber see this one of the Mac is available, and many subscribers yet request this application. Many subscriber has many too much request to this application. Service provider start migration to one optimal Mac on this Mac of the network operators. How it's okay. For our research, we try first we collect NetFlow data, then second data pre-processing, because for example point-to-point VPN packets for us it's not for us not needed. We need just or FTP packets. We need not we need not to we need just gaming, for example, and IoT application and another. Okay, it's pre-processing. Then with we use genetic algorithms. Okay, it's autonomous module. We use genetic algorithm. We predicted prediction, and the controller on Rex platform, controller of network, send request to Rex platform to start migration service or from service providers, and the service providers via Rex platform start migration and launch this application and make node. And so okay, here is diagrams how ICP, Internet Service Providers, network operators, service platform and service provider, how initializations and how migrate. So ICP connect to Rex, and the service provider connect to Rex. ICP published the information about available resource of each edge, and service provider became information of edge and analyze, and if is optimal edge, if in this geography zone is many requests for from subscriber, he requests for hosting. If request for hosting accept from ICP, application will start migration. We propose platform that could guide research in the post 5G area and looks potential 6G application scenarios. And in addition, it allows you place an application of service providers for a short time in the infrastructure of the network operator to improve the quality of the service provider, bring it closer and users or subscribers. Subsequent key potential features of 6G identity and necessary communication technology discussed. And finally, we have simulation, and simulation result provides that proposed proposed method can increase the network equipment efficient by more than 30%. And for us today, for this challenge, it's its main task is a third model. Third model is a forecasting model. It's autonomous model. For qualities as traffic forecasting, for its qualities is traffic forecasting tools. A generic algorithm is used. We have analyzed the traffic collected by NetFlow, and we make forecast for the next period times. Okay.
So Abdul, can you about dataset some few words?
Okay. How analyze? We have all ICP operator collect NetFlow traffic, NetFlow packets. What it is? NetFlow packet collection is stable. Is in this table right in which times, which protocols, source IP, source port, destination IP, destination port, and how many packet lengths and packet lengths. If we have many data from this collection, we can using many tools for prediction or for forecasting and prediction traffic. And for example, we have used genetic algorithms, but involved we have many another tools, machine learning, AI instruments, and others. For example, our platforms or model prediction models has this one's interface, and he predicted, for example, these applications. Every application has numbers, and how many probability of subscriber use this this application in each make notes. And okay, in our hosting, in our servers, we have many data collection from network collection, NetFlow collection. In these collections, we collect generally IoT applications, and the challenge task is with analyze this data set and in the dataset, most of the traffic is related to IoT application. Therefore, it's is proposed to group by yourself according. Go to the side and the forecasting mechanism. Challenge task is predict which application will be high load in in each multi-axis edge computing zones. Task is which applications, IoT applications, will be high load requested in each multi-axis edge computing zones.
Yeah. Okay. That I think about that challenge here, we tried to summarize some suggestions for the problems. Here, two problems is propose using machine learning model for recognition user demand based on the traffic surface allocation, and another one is with model for traffic forecasting, taking into account the traffic types of users demand in order to future surface migration. And in the last slide, you can I cannot move another last slide, Abdul. The last slide, last one. Yeah, this one. So here the links to our challenge. If you are interested, you can join. We can help to prepare the problem. We can help you to choose the problem and challenge to solve in your tasks. And also in here you can see the data set. You can check using the QR code, or you can email. You can contact us via email. We will share. So also the data set will be also included here in the challenge. Thank you. We are ready to answer your question. Abdul, do you want to add something more?
Yes, no.
Thank you.
Thank you so much, Abdul and Amar, for the webinar, introducing the webinar for today, as well as the challenge that you have described. I think Vishnu is here for the Q&A, so I would like to pass to my colleague Vishnu. Hi, Vishnu.
Yeah, thank you, Thomas. And it is a pleasure to talk to you, Amar and Abdu. Thank you for coming back again this year. Last year, we had a very successful challenge from the Russian host, hosted by your institute. So thank you so much for coming back again this year. This is a very interesting problem statement. In fact, the Rex platform, you had presented to us earlier also, the Rex platform. And that is, I think, a very important part. As I was telling you, it is a very important part. Amar, thank you so much for bringing that.
Thank you.
Mm-hmm. I have a question about the type of data. Is it a simulator? First of all, is it generated from the network or from simulator? And what type of application? I think Abdu mentioned IoT. If I heard that right, he mentioned IoT application. But what is the type of application that is used, and what type of traffic? Is it TCP, UDP, simulated traffic, IoT traffic? What is the type of data, please?
Type of data is TCP and UDP. It's not generated. It's real traffics. We collected just IoT of IoT applications. Mainly is IoT applications. There and UDP and TCP and first we must pre-processing this data, but type of collection is pickup. It's net flow traffic, net flow network packets.
Thank you, Abdul. So the participant has to parse the data using PCAP libraries. Is that how they access the packet data, or you have some tool to? You mentioned pre-processing. How the participant can pre-process? They have to write. They have to use PCAP libraries, or you have some tool.
Sorry, can you repeat? I did not understand.
How to access the packet data? Is it using PCAP libraries or some
Yes,
other tool?
in Python, Python has libraries, and on others you can convert to TXT and analyze like a text or like a list, and I think better is using pickup libraries of Pythons. I think in C has two these libraries.
Thank you so much. How the participant has to submit the model to you, in what format? Do you want the code? Do you want output CSV file or some other format for the machine learning model? Do you run it in your platform? How do you evaluate the submission?
It's like I mean in our challenge, right?
Yeah.
Yeah, they can. It's up to. They can submit like in GitHub, if using GitHub, if they want to. But some of them we can. I think the results will be also enough for us to. You unmute your. Okay.
Thank you. There are some questions here. What is the metric for network efficiency?
Excuse me.
Sorry, Abdul, go ahead.
I recommend to first convert this pickup collection to SQL or another database types, and the second analyze from this database tables. It will be better and fastly.
Thank you so much, Abdul. Yeah, that makes sense. Thank you so much. There is a question: what is the metric for network efficiency that improves by 30%? How do you measure the network efficiency? I think in your presentation, Amar, you mentioned 30% improvement. I think the question is, yeah.
This is Abdul. You can say. Okay.
Network efficiency is how many percent bandwidth of transport network is how many unloading network transport network. Network transport is network between core network and base station, where hosting make nodes. And yeah.
Thank you. The question, let me check. Yes, actually genetic algorithms. So you mentioned genetic algorithms. Can the participant use some other algorithm? I think Amar, Abdu, you mentioned already that the participant can use any type of algorithm, right? Can you confirm, please?
Yes, they can use another algorithms. Abdu used in these genetic algorithms, but machine learning and another algorithms also can be used.
Have you tried any other type of methods?
In this task, no, not yet. But we are planning to use.
Okay, I think Amar, in your presentation, you mentioned.
Particle swarm optimization.
Yeah.
Yeah.
Thank you. Yeah, that's what I was looking for. Yeah, thank you. Then there is another question. Could you please references? Yes. Related papers and references. If you could upload or if you could give some links in the challenge website. I think that will be great. If you put it in the challenge website,
Okay.
that will be thank you so much. Please please put those reference links of your papers in the challenge website.
Sure. Okay, we will do.
Thank you. Then criteria, Dina is asking, can you please elaborate first criteria, user demands based on traffic services allocation, predict user demand based on traffic service allocation. So the question is what exactly the user, the participant has to predict. Could you explain again, like what do they have to predict? You have traffic, now you predict that traffic for each MEC zone. Is that for each MEC zone you analyze the traffic and predict based on the MEC zone? Is that what the participant has to do? Could you please explain?
Yes, this is what they have. Abdu, can you?
Criteria to recognizing application for each users is how many you must in each time, for example, in every one time or 1 hour or every the 2 hour forecasting, how many predict which application requested by each users this application. For example, today users request cloud gaming today at 10 o'clock, and tomorrow he requests to at 10 o'clock to game clouding, and the third day, if your mechanism or tools predict that these users will be use cloud gaming, it will be good, and these users really at 10 o'clock request cloud gaming, it's good. Accuracy in this case is high, and when we have many data, criteria is how many find the for each users find for each user predict each there's applications, and and see how many query we have.
Thank you. Thank you so much, Abdu. There is a question about data. It is very big, huge data, 20,
Yes,
20 giga.
Yes,
Yeah.
it is 20 gigabyte in pickup, and when you unzip, okay, it will be 22. If you convert from a pickup to text, it will be 200 gigabytes. Yeah, it is many. We collect many data for better teaching machine learning.
Can you give a schema? Can you provide a schema? The schema of your data set. That's a question.
Schema is in pickup is standard, has a standard netflow standards. It's in every it's pickup standards. You can see in pickup standard of Cisco, and you can there find pickups schema.
Okay.
First time protocols, IP destination protocols, IP ports, and how many bytes is length of packets. It has a standardized schema.
Thank you, Abdu. Last question, Syed is asking, have you tried publish service based on Edge microservice platform? I think the question is that after the prediction, publishing of the service to the MEC platform, I guess that is the question. So in your experimentation setup in your lab, have you tried to publish this service? Does it, could you talk about that part of your work?
We have tried just in emulations in our testbed networks, and yeah, we try to publish our application in our testbed networks, and calculating how many unloading our transport networks in each area, and in real operators ICP networks, we can, of course, we cannot testing, but we have implant in our Russian operators. Maybe next year, the prototyping integrate our prototype.
Thank you so much. This is a very interesting problem statement. And as I told you before, Amar and Abdu already presented the Rex platform to us earlier also. So thank you for bringing this problem statement to us, and very interesting discussions during this Q&A also. I thank the participants. Thank you, Amar and Abdu, for staying back. We are past the hour. And patiently answering all the questions. If there are more questions, I suggest to engage them using this challenge website. Thomas is here, he can explain more. Slack is available also, Thomas will explain. Thank you, over to you, Thomas.
Thank you so much, Vishnu, for the Q&A session. We really appreciate. I would like to make a few announcements to our colleagues on the who joined today's session. Thank you so much, everyone, for joining. A very big appreciation for you, and also would like to thank our sponsors, Xilinx, who have sponsored this year's challenge. At this point in time, I would like to wish you a very good day. Bye-bye.